In this video, we are going to study some very important topics from the chapter Units and Measurements, first PUC Physics. In this, we are going to solve some problems related to dimensional formula. Here, there are three very important parameters. First one is length, which is denoted by capital letter L, and second one is mass, which is denoted by capital letter M, and third one is time, which is denoted by capital letter T. Here we can also denote displacement, distance, length, breadth and height by L. Using these parameters, we are going to solve some problems under dimensional analysis. First one, we are solving for velocity. In this first step is we have to define velocity. Here we know that velocity means distance by time, that is the ratio of distance by time. So in place of distance I will write L, because distance is denoted by L, and in the denominator we have time is denoted by T, so I wrote L divided by T. Next step is shifting the denominator to the numerator, so I can write L into t to the power plus 1 becomes t to the power minus 1, L into t to the power minus 1. Last step is in MLT form, that is m to the power 0, L to the power 1 and t to the power minus 1. Next we are going to solve for acceleration. We know that acceleration means velocity by time. So we already solved for velocity. So instead of velocity, I will directly write the dimensional formula of velocity, and in denominator we have time. We know that time is dimensionally denoted by t. So I'll write in place of time I write t. Next step is to shifting the denominator to the numerator. So it will become m0 L1 t to the power minus 1 into t to the power minus 1. Now finally writing it in MLT form, so we get m to the power 0, L to the power 1 and t to the power we have t to the power minus 1, again minus 1. We know that minus 1 minus 1 is minus 2. So we got the dimensional formula as m0 L1 t to the power minus 2. Next let us solve for force. From Newton's law, we know that force is equal to mass into acceleration. Now I will write the dimensional formula for mass as m into acceleration. We already know that m0 L1 t to the power minus 2. I substitute this one here. Then we have m to the power 1, m to the power 0. So I will write m to the power 1 plus 0, L to the power 1 and t to the power minus 2. Now our last step is writing it in MLT form. We know that 1 plus 0 is 1. So m to the power 1, L to the power 1, t to the power minus 2, which is the dimensional formula for force. Next, fourth question is for work. We know that work is equal to force into displacement. We already have the dimensional formula for force. I will substitute that one here. So instead of force, I will write m1 L1 t to the power minus 2 into displacement. Displacement is also denoted by L. So instead of displacement, I will write it as L. Next, writing it in MLT form, m to the power 1, L to the power we have L to the power 1 as well as again L to the power 1. So I will write L to the power 1 plus 1 into t to the power minus 2. Finally, we get m to the power 1, L to the power 2, t to the power minus 2, which is the dimensional formula for work. Next, fifth question is for volume. We know that volume means length into breadth into height. Here length also denoted by L and breadth also denoted by L, as well as height is also denoted by L. So I will write L into L into L. So we got L to the power 1 plus 1 plus 1, that is L to the power 3. So in MLT form, what we can write, m to the power 0, l to the power 3 and t to the power 0, which is the dimensional formula for volume. Next, let us solve a problem regarding to dimensional analysis. That is, verify dimensionally energy is equal to half mv square. Solution. Here we have energy is equal to half mv square. In this equation, I will write energy as E. E is equal to half mv square. Here we are neglecting the constant, so I will rewrite the equation as E is equal to mv square. We know that m means mass and v means velocity, so I will write it as mass into velocity square. Now we have to substitute the dimensional formula of mass and velocity here. Here we know the dimensional formula for mass, that is mass is denoted by m, into velocity dimensional formula we already know, that is m0 l1 t to the power minus 1 whole square is there, so I wrote whole square. Next step is multiplying the square inside, so I will get m0 l, 2 into 1 is 2, t to the power minus 1 into 2 is minus 2. Next step is to writing it in MLT form, so we get, so m to the power 1 plus 0, l to the power 2, t to the power minus 2. We know that 1 plus 0 is 1, so m1 l2 t to the power minus 2. Next question, verified dimensionally half mv square is equal to half mgh. Let us also check whether it is dimensionally correct or wrong. Solution. Our equation is half mv square is equal to half mgh. I already told that in this problem we are neglecting the constant, so I rewrite the equation as mv square is equal to mgh. We know that m is the mass, v square is the velocity. We already solved for mv square, that is in our previous problem m1 l to the power 2 t to the power minus 2, which is equal to mgh. Here we know that m is the mass, g is the acceleration, h is the height. So I'll write, instead of mass I wrote m, and instead of acceleration g I will write the dimensional formula of acceleration as m0 l1 t to the power minus 2, and in place of height I will write it as l, because height is dimensionally denoted by l. Now I'll write left hand side as it is, which is equal to, in right hand side we have m to the power 1 as well as m to the power 0. So m to the power 1 plus 0 is m to the power 1 into l to the power 1, again l to the power 1. L to the power 1 plus 1 is l to the power 2 into t to the power minus 2 as it is. Now we got in left hand side as well as in right hand side same equations, that means this equation is dimensionally correct. That is, we can also write that left hand side is equal to right hand side, so the given equation is dimensionally correct. If we get the different equations in left hand side as well as in right hand side, that is not dimensionally correct. Here we got both in LHS as well as in RHS dimensionally correct equation. Next question, check the correctness of the equation v is equal to u plus at, where v is the initial velocity, u is the final velocity. Solution for this question. Here we have the equation v is equal to u plus at, and we know that v is the initial velocity, u is the final velocity, a is acceleration and t is time. Here u and v is both are the velocity. First we solve. Here we are solving step by step. First I will solve for v, and next for u, then for at. First for left hand side velocity, v is equal to, we know that velocity is equal to m0 l1 t minus 1, as well as u means final velocity, that is also a velocity. So the same dimensional formula m0 l1 t to the power minus 1. Next we have at. At means acceleration into time. So I'll write the dimensional formula for acceleration as m0 l1 t minus 2 into dimensional formula for time is t. Now m to the power 0, l to the power 1 and t to the power minus 2 plus 1. So we get t to the power minus 2 plus 1. Minus 2 plus 1 means minus 1. So the dimensional formula for three different terms, for velocity, for u, for at, we got the same dimensional formulas m0 l1 t to the power minus 1. So the equation is, so the given equation is dimensionally correct equation. These are some important topics under dimensional analysis. Here we solved for some physical quantities as well as for dimensional equations. Thank you.